Hello everybody. This video is going to cover our 3.2 notes, which is triangle congruence and introduction to proofs. Whenever we are talking about proofs for this unit, our main goal for this unit is to prove that triangles are congruent. So we need to talk about congruence and then kind of, make our way into proofs. I do want to let you guys know that at the end of these notes, there is a page that says reasons for proof. So as I go through the introduction to proof, I'm likely going to be going like scrolling up and down so that you guys can see where I'm getting my information from. This will be available to all students. You do not get these on your quizzes or your tests. You have to just know what these reasons are and kind of what you're supposed to be looking for. But when we start learning how to do proofs, this is a really good resource for you to help you get comfortable with all of this stuff, okay? So the actual pages of the notes aren't very long. They look lengthy because of that one page or those two pages in there. Okay, so two geometric figures are congruent if they have exactly the same size and shape. In two congruent figures, all parts of one figure are congruent to the corresponding parts of the other figure. So what we need to do here is we need to write a congruent statement for the triangles. Then we're going to identify all pairs of congruent corresponding parts, and we're going to find the missing measures. So if you look at these two triangles here, notice that between the two triangles, we have angles that are marked congruent, and then we have sides that are marked congruent. All three angles within the left triangle are going to be congruent to the three angles within the right triangle, and hopefully you can kind of see what matches with what. For example, angle K corresponds to angle S. Angle J corresponds to angle T. They both have the three little arcs in there. And then angle L corresponds with angle R. They have the double arcs. Then if you look, line JL is going to correspond with RT because both of those lines have the triple congruency markers. I'm kind of running out of colors here. JK corresponds with ST because they have the single congruency marker. And then what color have I not used yet? Light blue? That one's fine. And then LK is going to be congruent to SR because they have the double congruency markers on there. Now, we are given some information here. We were given that these specific things have measurements to them. So they tell us that the measure of angle J is 40. So I'm going to go ahead and write this as 40 degrees. If J is 40 degrees, that means that T will also be 40 degrees because they're congruent. The measure of angle K is 110 degrees. And if that's 110 degrees, then that means that S is 110 degrees. JK, that segment there, is going to be 10, which means that ST will be 10. And then KL, this blue side over here, is 13, which means that SR is also 13. Okay, we need to write this congruency statement. It says triangle JKL is congruent to triangle what? Because our triangles are congruent, we must write our congruency statement in a very specific order. Whatever order they give us for the first triangle, we have to match that order for the second triangle. So because my first triangle started with the letter J, I need to start at the other triangle whose angle matches angle J, which for us will be angle T. So we're gonna start with T. And then from J, they moved over to K. So I'm going to jump over here, and I'm going to go from the triple angle marker, that blue angle, to the pink angle. So I have to follow that same pathway, blue angle to pink angle. So it's going to be S, and then they went from K to L, so I'm going to jump over that blue line. So from S, I've got to jump over the blue line to R, okay? The order matters, so you may want to make a note of that. Okay, so I'm going to erase some of this stuff so that we can see what's going on, but I wanted to show you kind of how to write that congruency statement. Okay, important piece of information. Notice that these first 6 items give you congruency statements, and then the last 3 items give you equal signs. Congruency statements mean that whatever they give you, whether it's an angle or a segment, the thing that you are going to write on the right-hand side will be another angle or a segment. If they give you an equal sign, that wants a numerical measure. So the bottom 3 that I've highlighted in orange, I don't want to put the measure of angle S equals the measure of angle K because that's not what it's asking for. It wants the number, the actual number for that angle. So here we go. I'm going to start with my very first option here, the segment JK. The segment JK is congruent to the segment TS. Order doesn't really matter when writing the segments, but I do try to follow the order as closely as possible, okay? All right, then I'm going to move over to segment KL. KL is blue and has the double markers on there, and that's going to be the same as SR, so we're going to put SR. JL is the orange line, that orange segment, so that's going to be congruent to TR. So again, when you have a congruency symbol, the left and the right side have to be the same type of thing. If the left side is a segment, the right side has to be a segment. Now we're going to move down to the angles. Angle J is going to be congruent to angle T. Angle K is congruent to angle S, and angle L is congruent to angle R. Then we're going to get down to the equal signs. And the equal signs, remember, are actual numerical measurements. So the measure of angle S is congruent to the measure of angle K. And since angle K is 110 degrees, then the measure of angle S will also be 110 degrees. The measure of angle R is supposed to be congruent to the measure of angle L. We don't know what angle L is, but we do know that we have a triangle. So I am going to pull out my calculator, and I'm going to do 180 minus 40 minus 110, and I get that this angle down here is 30 degrees, which means that the measure of angle R will also be 30 degrees. And then the segment ST is congruent to the segment JK. Both of those are going to be 10, and that is what you have to do for a problem like this. Okay, not too bad. Now that we know how to look at congruent figures, we're going to move down to the introduction of proofs. One thing that I do want to point out to you is you actually already know how to do these proofs. We just have to write them in a very specific way. So that's the part that's going to be the hardest, is you're going to look at this and say, I already know why that thing is the way that it is. But when it comes to proofs, it's not good enough to just say, I know what it is. You have to write down why things are the way that they are, okay? So let's say that you are given a line segment, and I tell you B is the midpoint of line segment AC, which is essentially what this is. Label point B on AC such that B is the midpoint of AC. Okay, so I'm telling you that B is the midpoint. So I'm going to come over here, and I'm going to label point B. If I have a midpoint, what does that then tell you is true about my segment AC? Well, if you have a midpoint, your segment is cut into two congruent segments, right? So we automatically know that AB is going to be the same as BC. We learned this back in 1.2 when we talked about the segment addition postulate. Okay, we talked about congruent segments. Actually, I think this is probably more of 1.3, but very similar, okay? So this says if B is the midpoint of AC, that means that B splits AC into two congruent segments. Therefore, we can conclude that segment AB will be congruent to segment BC. Like, you already know that. That's information that you already have in your brain, okay? What we've written has to be written in a very specific way. So when we write proofs in here, we write them as something called a two-column proof. Your first column will be your statement, and then the second column will be your reason, okay? So if you look down here, okay, here is the beginning of our two-column proof. And typically you'll see two-column proofs, they look like this, okay, where you have a segment for statements and a segment for reasons. So the statement, B is the midpoint of AC. How do you know that that's true? That was given information, okay? Since B was the midpoint of AC, we were able to conclude that AB was congruent to BC. The reason that we know that is the definition of a midpoint, okay? Now, you were given a midpoint, right? Given midpoint. In this document down here, okay, I want you to look at this very first thing here, okay? That first column is what you're given. You were given a midpoint. The second column is what you're supposed to find. So if you're ever given a midpoint, you have to write that down, and then you immediately say, I'm looking for congruent segments, because midpoint gives you congruent segments. Once you find those congruent segments, then you write something that looks like this. Segment whatever is congruent to segment whatever. And your reason will always be definition of midpoint. So anytime you're given a midpoint, the proof should have all of this information in there, just like we had in that proof that I just did for you, okay? Again, I'll come up here. You were given a midpoint. You had to find congruent segments. We found our congruent segments. What was the reason? The reason is definition of midpoint. You are allowed to shorthand because we're lazy here, and sometimes writing proofs take a little bit of time, so you may shorthand, but you still have to include all of the pertinent information, okay? All right, next we're gonna move down to angle bisector, okay? So I'm going to be giving you angle bisector information. Okay, if you're given an angle bisector, what are we supposed to be looking for? We're supposed to be looking for congruent angles. Once you find those congruent angles, you're going to write something that looks like this. Angle whatever is congruent to angle whatever. What is your reason that you're going to put? The definition of angle bisector. Okay, so all of your, this is like, what I like to tell kids is this reasons for proof sheet is your blueprint. Okay, it is your guide to help you write proofs. Once you know what you're given, it's really easy to figure out the rest of your proof. You just have to do the same thing every time. Okay, back to angle bisector. This first part says draw a segment EG such that EG is an angle bisector of DEF. So I need to draw, EG, and I'm drawing it so that EG is an angle bisector of the big angle DEF. Well, whenever you have an angle bisector, it cuts your angle in half, just like a midpoint cuts a segment in half, okay? This says if EG is an angle bisector, that means that EG splits angle DEF into two congruent angles. Therefore, we can conclude what angle is congruent to what angle. We would have to say angle DEG is congruent to angle GEF. But again, we have to write this proof in a two-column proof. So here you go. I've given you a statement, EG bisects angle DEF, that was given. What are we able to conclude from that given statement? That angle DEG is congruent to angle GEF. And then what did I tell you earlier that the reason was? Anytime you're given an angle bisector, it's the definition of angle bisector. It's right there in your blueprint. Sorry that I'm like scrolling around here, okay? So this is gonna be definition of, you must put angle bisector. You can't just say definition of bisector because there are all different types of bisectors out there. Okay, if you are given parallel lines, this is kind of one of the harder things to do, but anytime that you are given parallel lines, we have to find congruent angles. And I've been saying that in class. You guys, you have parallel lines, what are you looking for? And everybody's like, angle pairs. So that's what we're looking for, right? We're looking for congruent angles. Typically, we will be finding congruent corresponding angles or alternate interior angles. Those are the two main ones that we will see when dealing with proofs, okay? Now, something really important for you to note is that when you are given parallel lines, or if you're looking for parallel lines, we have to ensure that we use an if-then statement in our reason, okay? We can't just, it's just something that we have to do, okay? So, more information coming here, okay? If you're given parallel lines, you are going to be mainly focusing on congruent angles. I don't know if I've actually seen a proof that requires supplementary angles, but it can be there. However, you're gonna focus primarily on numbers 1 through 3, which is this up here, okay? So if we are given parallel lines, then we are looking for congruent angles. Once we find our congruent angles, we have to write angle whatever is congruent to angle whatever, and then your reason will be one of these three options, and it just depends on the angle pairs that you have. Did you have alternate interior angles? Did you have corresponding angles? Did you have alternate exterior angles? Again, exterior angles, not super common. Supplementary, not super common, okay? So let's go back up here, and let's look here. If given parallel lines, find the congruent angles. Okay, so they're telling us here that AD is parallel to CB. That was given. I don't know anything about DC being parallel to AB. So what I have to look for, now that I've got parallel lines, what am I supposed to be looking for, friends? I'm looking for angle pairs. The only angle pairs that I will know are the angles that are touching the parallel lines. So for me, that's gonna be angle 1 and angle 4, okay? That's the only thing that I know. So we're gonna say angle 1 is congruent to angle 4. The reason is, if lines parallel, okay, and again, I know that because they told me right there that lines are parallel. If lines parallel, then we can conclude that alternate interior angles are congruent because angles 1 and angles 4 are alternate interior angles, okay? Hopefully we see that. Now, I could have you do the converse of that, and let's say that I've given you congruent angles instead, okay, then we're looking for parallel lines. This is the converse of the concept we just discussed. So when using parallel lines, you must use an if-then statement in your reason. So right now they're telling us that angle 2 is congruent to angle 3. That was given to me, literally, right there, given, okay? what can I conclude from that? Well, what lines are those angles touching? They're touching the transversal AC, but they are helping me conclude that line segment AB is parallel to line segment CD. The reason is going to be similar to the one that we just did, but I wasn't given parallel lines. Now I was given congruent angles. So I have to say if alternate interior angles are congruent, then I was able to conclude that lines are parallel. Proofs are kind of one of those things that are going to require practice, but you will come to find out that it's the same thing every time you do a proof, okay? Nothing really changes. And the blueprint that I've created for you, I believe is super helpful. Oh my gosh, I said do not disturb, but it's still disturbing. Okay, so we need to just pay very close attention to all of that when we are, you know, trying to write our proofs. Okay, there we go. Now my do not disturb is on. Okay. Use that blueprint. Given perpendicular lines, this one's going to be the hardest, okay? Because there's a whole bunch of things that can happen. This is one of the last things that we talk about, but I do think it's important for you to kind of get a brief introduction of perpendicular lines. So we're just going to kind of throw ourselves in there. But again, don't panic. If you're given perpendicular lines, right here, they tell you what you're given, okay? When you are given perpendicular lines, these three things have to exist every time, okay? When you are looking for this first thing here, you're finding the first thing, that's how you write it. When you're finding the second thing, that's how you write it. When you're finding the third thing, that's how you write it. And then the reason for this first thing is here. The reason for the second thing is here, and the reason for the third thing is here. So this one gets a little bit tricky because there's a lot with perpendicular lines, but you have your blueprint to help you, okay? So let's look at this one. It says if you're given perpendicular lines, you can find right angles, then we can use our right angles to find congruent angles, okay? So the first thing that we were given is that AC is perpendicular to DB. That was given to us. When you have perpendicular lines, you know that perpendicular lines intersect at right angles, so we automatically know that angles 1 and 2 are right angles. So we're going to say angle 1 and angle 2 are right angles. That reason is definition of perpendicular. That is in our blueprint. I just know what it is already, but you would see that in your blueprint. And then once you know that angles 1 and 2 are right angles, then we can say, well, if they're both right angles, then they're going to be congruent to each other, because isn't it true that right angles are always going to be congruent to each other? We would say that angle 1 is congruent to angle 2, and that is all right angles are congruent. Now, as we do proofs, one of the things that I want to kind of point out now is that we are always wanting to write down congruency. Like we want to say that segments are congruent. We want to say that angles are congruent. That is really what is the meat and potatoes of proofs, okay? So even though this was important information, I really needed it for this. I really needed that to prove that 1 and 2 are congruent, okay? Just like all these things up here. I needed this. I needed this. I needed this. I needed all of these congruent things, okay? All right, moving on. There are going to be times where givens aren't necessarily needed, okay? We know that vertical angles are congruent. We've already learned that information. We don't have to prove that they're congruent. We just already know they're congruent. We don't need given information for that. So if you're just given this picture, you can automatically say that angle 1 is congruent to angle 2 because vertical angles are congruent. We just know that. Okay, that is also in here. It tells us this little section down here on the second page, these are things where you don't need a given. If you have vertical angles, cool, you got vertical angles. There's this thing that we're going to talk about in a second, the reflexive property. It's going to be there, okay? You don't need to prove that. And then you have congruent angles that are not due to parallel lines or vertical lines. That would be something called the substitution property, which we'll see at some point on here, I think. No, we won't. That's okay. All right, last thing that we're going to look at, because you don't see the substitution property very often. It says the reflexive property states that a segment, angle, or figure is congruent to itself. We will typically use this when triangles share a side. We do not need given information to use the reflexive property. So, do you see that you have two triangles here? And I like to draw them away from each other just so that you guys can kind of see what's going on. So this is triangle ADC, and then I can split it, and this is triangle ABC. But do we see that AC exists in both of these triangles? Okay. What they've done is they've taken those two triangles and they just kind of shoved them together. So both triangles are still sharing this side, but remember that our whole goal with proofs is to find congruent parts. And so we want to mention that AC is congruent to itself because that's true, right? AC would be congruent to AC down here. So we're just going to say that AC is congruent to itself. So we would say that segment AC is congruent to segment AC, and all we have to put for that is the reflexive property. Okay, so this is kind of the introduction to proofs. You are going to want to keep this page handy, okay, because this is going to be your blueprint, your lifeline, your savior when it comes to proofs, because every proof is, I don't want to say done the same way because they're not all done the same way, but like anytime you're given a midpoint, you're looking for congruent segments. Anytime you're given an angle bisector, you're always going to be looking for congruent angles. Anytime you see vertical angles, you're going to want to mention you got vertical angles. So you're going to see all of these same types of things in your proofs. And when you see them, they should all look the same within the proof, okay? I promise you, if this first day was overwhelming to you, it does get easier, okay? And I do think that you will find that by the time we are done with proofs, that you will feel very comfortable with writing proofs. It takes practice, just like anything else we do in math. If you have any other questions, please go see your teacher during their normally scheduled tutorial times, and I'll see you in the next video. Bye.